Alright, this is the last section of chapter 3, and it's part 2, so I just want to finish this up real quick. There's really not much more to say. If you have the median of each triangle, and the median is when you go from one side to the bisector of the other side. So, I don't know. This is just really rough still, so I still don't feel like constructing it right now. Hey, that actually worked. Alright, this point right here, where the three are concurrent, it's called the centroid. Alright, here's a nice pretty picture of it. Yay, it's so pretty. Woo. Okay, the distance, alright, the conjecture, we had a bunch of cool conjectures for the other ones. This one's kind of lame. The distance from a vertex to the centroid, I'm gonna write that. Distance from vertex to centroid is twice the distance between that centroid and the median on the opposite side of the vertex. I don't feel like writing it all out. It's an A. My handwriting is getting progressively worse. And my spelling. Median. Alright, so then if you knew this distance here is 2, and you knew that this is the centroid, therefore you would know that this distance is 1. Same with this one is going to be twice this, and this is going to be twice this. So that works that way for all of them. Alright, now I only have really one more comment on centroid. Then I may feel like going back and explaining something from a long time ago that I never got around to. Alright. The centroid that we just drew, that I'm going to draw again, because I'm cool like that. Hey, it works fairly close again. Okay, this point, the centroid, is also the center of gravity of that triangle. This isn't really important unless you're getting into engineering and stuff. But the centroid of that is the center of gravity. Therefore, if you cut it out on really good paper and find the centroid and stick it on the top of a pencil, it should balance there. If there was no wind and the paper was good. And all those other crazy little factors. Okay, so now we're done with that part. So I'm going to go back to something I was going to say in like chapter 1, but I never got around to. It's kind of fun. Alright, pool table math. Yay. If you have a big huge pool table, alright, if you hit the ball going this direction, it'll bounce back at exactly the same angle. So this angle is going to equal this angle. That's just the way it works. I'm not really sure why, but it does that. And then it keeps going and hits there and bounces off the same angle. Bounces off the same angle. Same, etc. And it makes pretty little patterns like that. Cool. So then, if I told you that this angle was 30 degrees, and I wanted to know what this angle is over here, you could go, well, this one right here is 30 degrees. And we know that this right here, see this big triangle? This is 90 degrees, plus 30 is 120, so then this is 60 degrees. Then we know that this one here is 60 degrees. 90, 60, this is 30. And that's 30, because it bounced there. Now 30, 90, wait. Okay, this isn't the triangle there. 30, 90. I lost my train of thought. I'll figure out what I was trying to say at some point here. What on earth was I gonna say?
Can we figure out these interior angles here?
Well, these aren't parallel lines.
I know.
If they're parallel lines, you could.
Interior, but the square thingy.
The square, well, we know that this right here, let's see, 30 and 30 is 60, so we know this right here is 120. We know that 20 and 20 is 120, so that this right here is 60. Yeah, that's kind of pretty. Alright. We know that. Okay, I'm not really sure why I brought this up, because apparently I can't figure it out right now. It's kind of early in the morning, so don't blame me. But usually, if my brain was in a functioning state, you'd be able to figure that out. So, that should be all. But you can only do that if you know it's a setting like this, where something is moving and bouncing off of other things. Because if someone just gives you a shape, you know, and asks you to find certain angles, you can never assume stuff like that, because things, unless they're actually bouncing. Thank you, Marker, I really appreciate that. Alright, you can't just assume, hey, if there's a box, that this angle and that angle are going to be the same, if somebody's just drawing in arbitrary angles. So that only works in like pool and very select cases, but it's fun. So yeah, I'm sorry that this hasn't been a very productive session, but that should top off chapter 3.